going to do section 8.2. I want to work on it for today and tomorrow. So my plan is to teach it all today, and then tomorrow give you time in class to work on your WebAssign, ask me questions, that sort of a thing. And then on Thursday, we'll start 8.3. Everybody got that? All right, so yesterday we talked about just basic sequences and series. What a sequence is, what a series is, that sort of a thing. Today we're going to talk about arithmetic sequences. You can also call it arithmetic, but you'll hear it pronounced a lot, arithmetic. And an arithmetic sequence has consecutive terms that have a common difference, okay? A common difference. This is going to come into play for all of your arithmetic. You're going to have to find the common difference. Another way that you can think of that is the slope. Why can you think of common difference as the slope? Because arithmetic sequences are linear. What does that mean? If you were to graph it, what does it make? A line, okay? What does a line have? It has a slope. All right, so when you are asked if something is arithmetic, the way that you would tell if it is or not is if you add or subtract the same number to get from one term to the next. To get from one term to the next. If your function, if your sequence is arithmetic, you will add or subtract the same number to get from one term to the next. It's a constant value, plus 3, plus 3, plus 3. Minus 7, minus 7, minus 7. Your arithmetic functions have a common difference that is the same thing you add or subtract each time. All right, everybody understand that? Let's look at some examples here. Look at A. This is your rule. So on WebAssign, they're going to ask you, they're going to give you this, and they're going to say, what's the common difference? What's the slope? If you were looking at that, what would the slope be? It's a linear function, same as y equals mx plus b. So it's a sub n equals something n plus or minus another number. So your common difference here would be 4. What are you doing to get from the one term to the next? Well, look at your sequence. From 7 to 11 is what? Plus 4. From 11 to 15? Plus 4. From 15 to 19? Plus 4. Now, I'm going to give you a formula here in a second, so you don't have to even really do any thinking. But think about it this way. I want you guys to see how this is related to a linear function. Do you guys agree with me that 7 is the first term, right? And then 11 is the second, 15 is the third, and 19 is the fourth, right? So if you're adding every single time to get to the next number, you're adding 4, how would you find this term, the one before it? You would subtract. What's 7 minus 4? Positive 3, right? Which is right here. In a linear function, if this is your x and this is your y, this would be your y-intercept, right? When the x value is what? 0. So the way that I want you to see how they're related. A linear function is the same thing as an arithmetic sequence. It's going to have a constant number that you add or subtract every single time to get to the next one. And the constant will be the y-intercept, or the 0 term. So if you look at something like this, all right, it's not written in quote-unquote standard form, but you can tell me what the common difference is. How'd you get from one number to the next? You subtract 5, minus 5. So if they were giving you this sequence and you had to write the rule, you would say, okay, first, let me figure out how they get from one term to the next. What's 2 and a negative 3? Negative 5, right? How'd you get from negative 3 to negative 8? Negative 5. From negative 8 to negative 13? Negative 5. Agreed? Okay, so that's your common difference. So think about it this way. If this is my first term, second, third, how do I get the 0 term? Instead of subtracting 5, we would do what? Add 5. What's 2 plus 5? 7, which is right there. Do you see the relationship, the correlation? So there's a couple questions on WebAssign that just says, is this an arithmetic sequence? And you guys are going to be like, how do I know? How do you know? If it's a linear function, doesn't have any exponents that are variables, and you add or subtract the same thing to get to the next term. That make sense? Okay, let's scoot here. I changed the order of the slides a little bit, but here is the formula for an arithmetic sequence. If you don't like thinking of finding the slope and then the zero term, you can use this. What is a sub 1? That's the first term, good. N is your term number. And then D is the what? The common difference, also referred to as, since it's arithmetic, it's also the slope. How'd you get from the one number to the next? So in a super basic question, like example 2, it says find the formula. Sometimes they'll say write the rule, same thing. But for a sequence whose common difference is 3, so your D value is 3, then your first term is 1. I'm sorry, your first term is 2. A sub 1 is 2. So if I use this formula right here, I have my rule. A sub n equals, the first term is 2 plus n minus 1 times what? 3? What do I do with the 3? Distribute. So it's 2 plus 3n minus 3. And now what? Add what? So a sub n equals 3n minus 1. So now if I said to you, okay, what is the 943rd term? You say 3 times 943 minus 1. Right, so once you, if they ask you to find a specific term, in order to do that, you have to write the rule first. That makes sense? What would that be? What's 3 times 943? 2, what? 28, 28 minus 1. Okay, so it, got it. This is a 9. So the 943rd term is 228, 28? Okay. That's fine. Does that make sense, though? God bless. All right, I skipped example 3. We're going to come back to it. All right, let's talk about a question like this. Find the 54th term. I want to find a sub 54. Well, how many terms do I know? I know the first one, the second one, the third one, and the fourth one. So conceivably, I could count, right? I could figure out how I got from one number to the next and just do that 50 more times, right? Okay, we're not going to do that. What are the 2 things you need in order to write a rule? You need your a sub 1, perfect, and you need the common difference, the D. Right? I can't figure out what the 54th term is if I don't know what this rule is. So what is the first term here? 2. What's the common difference? How'd you get from 2 to 9? 9 to 16. 16 to 23. Okay, good. So what's your common difference every time? 7. Now you can go about this 2 ways. You can plug it into the formula. So a sub n equals the first term plus n minus 1 times 7. Now what do I do with the 7? Distribute. So 2 plus 7n minus 7. So your rule is a sub n equals 7n what? Minus 5, okay? You could do it that way, or you could say, what's my 0 term? I know my slope is 7, so it's 7n. If I'm going forward, I'm adding 7 each time, so if I go backwards, I do what? What's 2 minus 7? Negative 5? Is that the same thing we got there? Okay, so whichever way you want to look at, I just want you guys to see the correlation between arithmetic and it's just a linear function. Now, my suggestion to you, before you guys go and now plug in 54, because I know you know that's the next step. A lot of times when we're doing this, it's pretty simple, so we make a silly mistake. You miss a sign or something like that. I would just take a second to check. If I plug in 4, or if I plug in 3 or something, whatever term number you plug in, you should get that number out, right? Like if I plug in 4, what number should I get out? 23. Let's just check. 7 times 4 minus 5. 28 minus 5 is 23, right? 23? Okay, so that means my rule is correct. That's a good way to kind of check to just see if you made a mistake. Say you had a minus and it should have been a plus or something. You could check a silly mistake there, because once you get the rule wrong and then the term is wrong, then everything's messed up. So now that you've checked to say, hey, that's the right rule, so we're going to use this rule. So my rule is 7n minus 5, correct? Okay, so what are we plugging in? If we want to find the 54th term, 7 times 54 minus 5. What is 7 times 54? 378 minus 5. So the 54th term of this sequence is 373. That makes sense? All right, so now let's do a couple different things. First of all, I see the word sum. What does that mean? Addition. Okay, good. We're going to talk about two different kinds of sums. We're going to find the sum of a finite arithmetic sequence and then the partial sum. Here is the formula for this. Let's talk about what all these things mean. N is the number of terms. How many terms are we adding together? A sub 1 is the first term. And then A sub n is the last term. So in order to find the sum, in any case when they ask us about an arithmetic sequence, whether it's finite or partial, and it says, find the sum, you need to know how many numbers you're talking about. You need to know the first term, and you need to know the last term. So, yeah.
Are we going to be given the formula?
Probably not all of them, but you'll get like these ones. Probably not the basic one, like the first one we did. All right, now guys, obviously I know that you could add these together and tell me how much it all equals, right? That's not what I'm asking you to do. A lot of times you'll be given where it doesn't start with 1. There's a lot of them in between, you know, something like that. This is just a very basic one to just kind of show you how this works. But the sum formula is n over 2 times the first term plus the last term. How many numbers are we dealing with here? Count them. Okay, there's 10. If you ever have to count, I'd count twice just to make sure. So what is the first term? 1 plus what is the last term? 19, okay. So order of operations tells us to do what first? Okay, so your parentheses. So this is 20. What's 10 divided by 2? 5. So the sum of this finite arithmetic sequence is 100. All right, simple enough. Could you take your calculator and add them up and just make sure you got it right? Yes. Yeah.
Are we going to get that formula?
Yes. Yeah.
If we just add it up on the test, will it, like, or do you want us to?
No, you have to, if you just add it up on the test, you're not going to get credit for it. All right, let's look at this one. We're finding the sum. So let's talk about the sum formula. Right? Okay, find the 150th partial sum of the arithmetic sequence, blah, 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 blah. Well, I already know how many numbers they want me to add together. How many? 150, yeah. Well, because do you have an ending point here? No. This is a sequence that goes on and on and on and on forever. They just want to know what the first 150 of them are when you add them together. So I know how many numbers I'm adding together. I know what my first term is. What? 5. What do I need to know now? I got to know the last term. How can I figure out what the 150th term is? I got to plug it into the other formula thing. Do I have the other formula thing? No, I got to figure it out. In order to do the other formula thing, I agree. You got to write the rule for this. What are the two things you need for the rule? The first term and your common difference. Okay, well, what is the first term? 5. How did you get from 5 to 16? At 11. How'd you get from 16 to 27? How'd you get from 27 to 38? Okay, so your common difference is 11. Agreed? So let's plug it into that formula. A sub n equals 5 plus n minus 1 times 11. What do I do with the 11? So 5 plus 11n minus 11. What's your rule? Uh-huh. Good. Now, another way, again, if you wanted to look at it as your xy, this is my first term, right? So if I needed my 0 term, I already know that my slope is plus 11, my common difference. If I'm adding 11 to get to the next term, how would I find the one before it? Subtract. What's 5 minus 11? Negative 6, which is what we have in our formula, correct? Another way you can check is say, so this is my first term, my second term, my third term, my fourth term, my fifth term. Well, what happens if I plug 5 into the formula I just created? What should come out? 49. So let's go ahead and check that. Just check, just to make sure. What is 5 times 11? Minus 6. So then you know your rule is good.
Can you do it with any of those numbers though?
Yeah. No, you can do it with any of them. Try with 2.
22.
Minus 6. There you go. So that's a good way to check. So did I figure out what my last term is yet? No. But now I take 150 and I say, all right, let's find the 150th term. What's 11 times 150? 1650 minus 6. So the 150th term is 1644, yeah? So now do we have enough information to find the sum? Yes. So to find the sum of the first 150, I say 150 divided by 2. And then I have my first term, which is 5, plus my last one, which is 1644. Parentheses first, so 1649. And then 150 divided by 2 is 75. So when I add this sequence, when I add the first 150 terms together, what's the sum? 123,024. 124,425. Did you guys get the same thing? All right, do it again. That's okay. Just check. That's all right. That's all right. Don't worry about it. That's why we're playing around with our calculators. What's 75 times 1649? 123, 685? 75? Chris, did you get that? No, you did? Okay. No worries. You might have put the numbers backwards. No big deal. As long as you understand how we got there, you're good. All right. Nothing in here, guys, is so incredibly difficult. If you have a function, I'll do the last one in a second, but say you have something like this. There's something like this on your web assignment. And it says, is this an arithmetic function? Is it? No. Where is there an exponent in the, is there a variable in the exponent? Yeah, so right away you're like, wait, this isn't a linear function. So your answer would here be no. You can still plug numbers in and evaluate it. You can find out what the first term is. What would a sub 1 be? 2 to the first plus 1, so the first term here would be 3. All right, so you could go through and evaluate, but then it's going to ask, what's the common difference? If you read the directions in WebAssign, it says, if it's not arithmetic, your common difference answer is none. So don't come up and be like, what do I put here? I'm going to just tell you to read the directions, so be careful with that. All right, last one I want to look at. If it's not arithmetic, there's no common difference. All right, let's talk about this question. You're going to see a question like this on WebAssign. You're going to see it on your test. You're going to work it differently, whether it's an arithmetic versus a geometric. But what do we remember that arithmetic functions are? Okay, linear, important to remember. What do we know about a linear function? It has a constant what? Okay. So what did they tell me here? The fourth term, a sub 4, is what? 20. And they told me that the 13th term is what? All right, so in order to write a rule, I have to have the first term and the common difference. Do I have either of those things? No. So here's the rule. Right? So, what do you think we should try to find first? Okay, I don't hate that. So just think, if we found n, right? If we found n, we still have two variables unknown, right? Okay. See if anybody can. Why? How could I agree we should find d, but how would I do that? I agree.
Can we use the other one? Oh, no, 'cause that's what it's on.
Look at all the words that are written in red.
This slope is kind of like the same.
Can you find the slope? Think about this. First term is something. Second term is something. This is your x and this is your y, isn't it? Did they give you an ordered pair?
Oh, 4 comma.
4 comma what? Why can I say 4 comma 20? Because that's an x and y. Because what kind of a function do we have? Linear. What's the other ordered pair? What's the other ordered pair? 13 and 65. So what did you just say, AJ? Let's find the slope. You can do point. Let's just find the slope here. You're fine. I know what you mean. This is your x. This is your y, right? So I'm going to say 65 minus 20. Can you say 20 minus 65? Sure. So now I'm going to say 13 minus 4. So 65 minus 20, 45, over 13 minus 4 is 9. So my common difference is 5. Okay, my common difference is 5. Now, from here, you can problem solve. On your test, I will probably not give you one where it would be easy to problem solve. What I mean by that is, think about what they've given you already. They gave you the fourth term is 20, right?
So when you just have to like,
So how, I mean, could I theoretically work backwards and find that first term? Yeah, if I know I'm adding 20 to get to the, adding 5, what would the third term be? 15, then, okay, so then you could figure it out that way. I probably will not give you one that you can do that. So I'm going to show you mathematically how we're going to use this formula and find the information. Now, AJ, I'm going to go back to what you had said originally, find n. We can do that now because we know n. Okay, look, you're going to take this formula, a sub n equals a sub 1 plus n minus 1 times d. I'm going to do this two different ways. We are going to find this first term mathematically, not counting backwards. What two terms do I know? I know the fourth term, and I know the... So think about it, guys. What is the fourth term?
20.
What did I just do there? I just plugged in the fourth term, and then in the formula n minus 1, I said, oh, that one was the fourth. How could I do it with the 13th term? 65 equals what? 13 minus 1 times 5? Okay, this always works, guys. Every single time you have an arithmetic function, you find the slope, and then you pick one of the points. It doesn't matter which one, you're gonna get the same answer. But you can work backwards. What is 4 minus 1? 3, and 3 times 5 is, right? And then how would I solve this? I'm going to subtract 15 from both sides, so I get that my first term equals how much? 5. So over here, I'm going to do the same thing. What is 13 minus 1? 12. 12 times 5 is, so 65 equals a sub 1 plus 60. Subtract 60 from both sides. What's your first term over here? 5. And now once you know the common difference and the first term, God bless you, you guys can find all of the terms. All right, there is going to be a question on WebAssign, 1 or 2.
So a sub n is 5.
Oh, the rule?
Yeah.
Yeah. So say you have, and I'm going to draw this incorrectly, but just work with me, all right? Say I have n equals 1, and this is 200, and it's 2n plus 7. We did this yesterday, right? This is finding the sum. What do they want me to start with? 1. What do they want me to end with?
200.
Okay, so I want to start plugging in 1 and then 2 and then. So do you guys want to do that 200 times? No. Didn't we learn a formula today to find the sum? It's n over 2 times the first term minus the last term. You guys agree? So how would you find the first term? You'd plug in 1. So to find the first term here, you would say, okay, I'm going to use 2 times 1 plus 7, and I get my first term would be what? 9. Okay. So then to find the last term, what number would I plug in? So 2 times 200 plus 7 is what? 407? What's 200 times 2? 4, like plus 7, so 407. So do you have now the first term and the last term to plug into the formula? And do you know how many terms you're talking about? Yes, how many? I know it's 200 because I'm starting with 1. If you were, we'll talk about this more tomorrow. If you were starting, like say they told you to start with n equals 6. You're going to have to say it's n minus top minus bottom plus 1. I'm going to say it a million times. So you would take the top number, 200, minus 6, and then add 1. I'll do a couple of those with you tomorrow. As long as it starts with 1, you're fine. You know, it's the top number is how many numbers you have.
Yeah, but what are
Oh, if you were going to work this out, okay, it would be 200 over 2 times 9 plus 407. So it'd be 100 times, what, 416? So the sum of the first 200 numbers of that thing I just made up was 41,600. Now, if it starts with 1 on the bottom, you're good to go. If it starts with any other number, whether it be 0 or like 12, you have to remember to do top minus bottom plus 1, because that'll account for, is it 200 or is it 201? Do I count 1? Do I not count 1? You know what I mean? Like, do I count the one I started with? Whatever. Just say top minus bottom plus 1 every time. What's 200 minus 1? 199 plus 1? There you go. So you guys should be able, if you want to do your web assign now, you can. You do not have to. I'm going to let you guys work on it in class tomorrow, because then that helps, allows me to be able to answer some questions for you if you guys want to troubleshoot or whatever. So you do not have to do this tonight. You will have time in class tomorrow. But you could probably get some of it just knocked out, the less complicated ones, we'll say. Yes, sir.